Dear students, in last class we have studied the ionization processes. In that we have studied ionization by collision and photoionization processes. Today we shall discuss secondary ionization processes. To understand secondary ionization processes, we shall have a recap on the discussions in last classes. To understand secondary ionization processes, we shall have a recap on last class. Ionization by collision we have studied in last class. In ionization by collision process, a gas atom or a molecule was collided with a free electron released from or emitted from the cathode, to which a voltage was applied. That voltage was of sufficiently higher magnitude to release free electron. After collision, from the gas molecule or atom, an electron was dislodged. So here I had written from gas, atom or molecule. That means this electron is released from the gas, atom or molecule here. When that gas, atom or molecule lost one electron, it had become a positive ion. But what was necessary here? For an atom to lose one electron, the kinetic energy of the free moving electron should have been more than the ionization energy of gas, atom or molecule. Same thing happened in case of photoionization also, but a small difference was there. What was that difference? There, the electron released from the cathode was not due to the applied voltage, but it was due to the photo radiations that were incident on the cathode. And we had written an equation to explain the entire process in this way. So this equation we had written: gas atom collided with free electron released by the cathode due to photo radiation incident on it, with a condition that the energy gained by the electron between the collisions, that is kinetic energy gained by the electron between the collisions, being more than the ionization energy of the gas atom, an electron was released from the gas molecule or atom, and gas atom or molecule had become a positive ion, and this electron is free electron, which we have shown on the left hand side. Now these two equations, one equation for ionization process due to collision and other equation written for photoionization process, are very important to understand secondary ionization process, because to explain secondary ionization process we make use of the positive ion produced here. the gaseous discharge takes place only if the secondary electrons continue to dislodge electrons from the molecules of gas between the electrodes. So if this does not happen, then what will be the result? If it does not happen, then the electrons released and the ions will recombine, and once again the neutral atoms of the gas will be formed, and hence the discharge of the gas would not take place. The secondary ionization process may be explained briefly by considering A electron emission due to positive ion impact. B electron emission due to photons. C electron emission due to metastable and neutral atoms. First we'll take electron emission due to positive ion impact. We have seen that positive ions are formed due to collision of a free electron with gas atom or by photoionization process. And these positive ions travel towards the cathode, as there is positive charge on the gas ion and negative charge on the cathode. Positive ions formed due to ionization by collision or by photoionization and being positively charged. They travel towards the cathode. That means if we are having here a cathode and anode arrangement as shown. Here I will not draw a complete figure. To assume that all the necessary components are there. Now this is anode. Due to the collision between free electron and gas atom, positive ion will be formed. I am representing gas atom by A here. A plus means what? It is positive ion of the gas. And this is what? This is free electron, E minus. And when it collides, ion is formed from the gas molecule or atom and a secondary electron is released. Now this electron keeps moving towards anode because there is force of attraction between positively charged and negatively charged bodies or particles, you can say. A positive ion approaching a metallic cathode can cause emission of electron from the cathode by giving up the kinetic energy on impact. If the total energy of the positive ion namely the sum of the kinetic energy and the ionization energy is greater than twice the work function of the metal then two electrons will be released, of which one electron will neutralize the gas ion and other will start moving towards the anode. This is nothing but a secondary electron. So what is happening in this entire process is positive ion here on colliding with the cathode will give two electrons if and only if the total energy of this positive ion, namely the sum of kinetic energy and the ionization energy is more than twice the work function of this metal used in making cathode. And out of those two electrons, one will neutralize the gas ion and another electron will start moving towards the anode. And this electron which moves towards the anode is nothing but secondary electron. But you should know what is work function. To understand, work function is nothing but the minimum amount of energy required to dislodge an electron from the surface of metal. If energy given by this positive ion to the metal on impact is twice the work function, then 2 electrons will be released. If it is slightly higher than 1 work function, then only 1 electron will be released. And the work function is measured in terms of electron volt. The unit of work function is what? I hope these things you have studied in your 11th or 12th standard. EV. That is electron volt. Next we will take up electron emission due to photons. You all have studied that photons are energy packets. If photons having sufficient energy that is higher than surface potential barrier of the metal used in making cathode. Say for example, here we are having a cathode. And here is anode. On this cathode, if energy packets are incident and if these energy packets are having sufficient energy, that is their energy is higher than surface potential barrier of the metal used in making this cathode, in that case each of these packets will be releasing or dislodging electrons from the cathode surface. So when these photons hit this cathode, then what happens? Electrons are emitted by the cathode. So what is the condition for that? Condition is the energy content of the packets that are incident on the cathode should be more than surface potential barrier of the metal used in making cathode. What is surface potential barrier of the metal? It is the threshold energy. If a particle having energy higher than that threshold energy are made to incident on the cathode or that metal surface, then an electron will be given out. And from where do we get these photons? Such photons are found in light rays. Such photons are found in light rays, or you can say they are there in radiations. For example, you can consider ultraviolet light. If a photon of UV light having energy higher than surface potential barrier of metal used in making cathode, then electron emission from the surface of cathode occurs. For this to happen, we must use ultraviolet light of suitable frequency. That is Planck's constant into nu must be greater than or equal to psi, where psi is the work function of metallic electrode. The nu is given by the relationship frequency nu equal to psi by h, known as threshold frequency. If the incident radiation has a greater frequency than the threshold frequency then the excess energy goes partly as the kinetic energy of the emitted electron and partly to heat the surface of the electrode. So what happens here? If the incident radiation has a greater frequency than the threshold frequency, that is minimum required frequency, then the excess energy, because higher frequency means definitely there will be higher energy content. Therefore, the excess energy goes partly as the kinetic energy of the emitted electron and partly to heat the surface of the electrode. That means there will be energy distribution. Dear students, I will stop the class here and continue in next class with electron emission due to metastable and neutral atoms. Thank you.